As VR experiences continue to gain popularity, user expectations for seamless experiences are rising. To meet these demands, network engineers must make informed decisions when designing 5G networks. Identifying network performance thresholds where the quality of experience significantly drops is essential to delivering what users expect from next-generation VR applications. To study this, we built a complete testing system that combines 5G network emulation with VR performance monitoring. Using NVIDIA Siona, we modeled realistic network conditions and used them to build simulations that inject latency into the system with Windover, an open-source network traffic manipulation tool. We validated each simulation using ALVR, a real-time monitoring tool. Users played games under one of three network conditions. The first is baseline Wi-Fi, which is representative of a private home VR setup with around 80 milliseconds of end-to-end latency. The next is close proximity 5G, which simulates a VR experience on a 5G network with 10 concurrent users around 125 meters from a tower, producing 110 to 130 milliseconds of latency. The last one is long-range 5G, which increases the concurrent users to 20 and the distance to around 500 meters from a tower, resulting in 190 to 210 milliseconds of latency. Each of our 60 participants played in 3 random scenarios using the Meta Quest Pro and then completed a post-session survey after each one. The games tested 2 styles of interaction. With Balloon Night, we tested a physically demanding 360-degree VR experience where players use motion controllers to pop floating balloons with virtual swords. The game requires full body movement, quick reflexes, and continuous spatial awareness, making it especially sensitive to visual lag and motion delay under poor network conditions. With Whack-A-Mole, we test a front-facing, stationary VR minigame where players strike appearing targets using handheld mallets. It involves fast reaction time but minimal body movement, which makes it more resilient to network impairments and a useful comparison point against motion-heavy gameplay. Our results were clear. The base case Wi-Fi scenario delivered the highest overall quality of experience, with scores averaging above 4.0 in every category. Under long-range 5G conditions, quality of experience dropped by nearly 20%, with users reporting lag, screen tearing, and overall discomfort. Balloon Night was affected the most due to its high-motion gameplay demands. Future studies that explore other forms of network degradation, like jitter, packet loss, or bandwidth fluctuation, can use our results as a foundation. Together, they can give 5G providers a clearer picture of what aspects to prioritize, whether that's latency, packet drops, or stability under load. What we found is simple but powerful. Latency around 200 milliseconds significantly reduces the quality of experience, especially for motion-intensive VR games. As 5G network strength drops under long-range conditions, network engineers will need to make informed decisions on network design and optimization to maintain the best user experience possible. Thanks for watching.